Hi friends, welcome back to Ryan's Routing Table. My name is Ryan, and today we're doing yet another video in my Networking 101 series. Today's video is about subnetting. Subnetting is a big, scary topic. A lot of people are really confused about it, and today I'm going to do my best to break it down for you, explain some of the concepts, and why we even need to worry about it. So if y'all are ready, hold on to your butts and let's dive right in. In my last episode, we learned that every IP address has a network portion and a host portion, but who decides where that split happens? You do. That's subnetting, and today we learn exactly how that split is decided. A subnet mask is a second number in the same dotted decimal format that marks which bits of the address are network and which are host. In this example, we have the subnet mask of 255.255.255.0. The 255s mark the network bits, and the 0 marks the host bits. The first three octets are the network, and the last is the host. The subnet mask can also be expressed as what we call a CIDR notation. It is a direct expression of the 1 bits in the mask. The first octet is 8 ones in binary. The second octet is 8 ones in binary, and the third octet is 8 ones in binary. So you add all those together to get a 24. CIDR notation is always expressed by a slash and then the number of bits that are turned on in the network address. So that's exactly what a /24 means. A /24 equals a mask of 255.255.255.0. The mask and the CIDR notation are basically two ways of saying the exact same thing. So when we talk about subnetting, you may also hear people say borrowing a bit. And this is what we mean by that. So when we're borrowing a bit, what we're doing is we're borrowing a bit from the host portion of the address and giving it to the network portion of the address. So you can see here, the final octet of our address here in a /24 is all zeros, right? So our baseline is no bits borrowed, 1 network, and 256 addresses in that network. If we borrow 1 bit to make it a /25, then we get 2 networks. And those 2 networks have 128 addresses each. And this continues down the line. So if we borrow 2 bits, we make it a /26. That gives us 4 networks with 64 addresses each. So you can see every time we borrow a bit, we double the amount of networks and we have the amount of addresses in each network. Here I've created a quick CIDR notation reference chart. You can see on the left we have the CIDR notation followed by the equivalent subnet mask, the total addresses in that network, and then the amount of usable hosts. We'll get into the usable hosts a little bit later on. You can see that every time we borrow a bit from the host address, that also changes the subnet mask to reflect the binary number that we create by changing that host address to a network address. So a /25 is going to end in a .128 because 100000000 in binary is 128. So then when we add another bit to that, to make it a /26, then that becomes a .192. So diving deeper into the usable range of each network, you might be wondering, if I have 256 addresses in the network, then why can I only use 254 of them? And that is a great question. There are 2 addresses in every network that are unusable by the hosts that are in that network. The first is the network address. That is the very first address in every network. That is reserved for identifying the network itself. This is saying, in this example here, this is saying, I am in the 192.168.1.0 address range. Think of it like an apartment building. The number on the outside of the building is used to identify the building itself, but it's not actually addressed to any individual residents inside that building. Each of those units inside the apartment needs its own address so that we know where to send packages or where to send letters to each individual resident in that building. So the network address is like the apartment building number, basically. And then the other unusable address is the final address in every network. In this example, it's going to be 192.168.1.255, and we call this the broadcast address. So on networks, equipment has the ability to send traffic to every host on the network. And if it does that, it uses the broadcast address. There's several protocols that require use of broadcast. We'll dive more into those in future episodes. But for now, just know that the broadcast address is the final address in the network, and the network address is the first address in the network. So everything in between is the actual usable range So here I have an actual subnetting example of what this looks like. In a /25 network, the two networks that we have available to us is going to start with subnet A here as it's labeled. The network's going to start at 192.168.1.0. That's the network address, so it's not usable by a host. And the broadcast address is going to end with 192.168.1.127. The usable range in there is going to be .1 through .126 with 126 available hosts. And then the network B that I have here is going to start with the .128. So that's going to be the network address. And then it's going to be a 255 for the broadcast address. And the usable range is going to be in between the 129 and the 254 range. In another example here, we can go farther. We can borrow 2 bits to make it a /26, which gives us 4 networks. So we're going to have 4 different subnets here, starting with .0 through .63. And then we're going to go to .64 to .127, .128 to .191, and .192 to .255. So let's get into the practical reasons of why we subnet in the first place. The first reason is organization. You can use this to separate departments, you can separate buildings or device types into their own logical networks. Also security. You can isolate sensitive systems, so a breach in one subnet doesn't automatically expose another. Another good reason is performance. Smaller subnets mean smaller broadcast domains and less unnecessary broadcast traffic. Another reason is efficiency. You can allocate only as many addresses as a segment actually needs. So a quick recap. The subnet mask, or the send notation, like /24, marks exactly where network bits end and host bits begin. Every subnet reserves a network address and a broadcast address. Neither is assignable to a host on that network. And borrowing bits creates more smaller subnets. 1 bit doubles the subnets and halves the hosts. On my next episode, we'll be discussing ARP. Now that we can build and split networks, next time find out how a device finds another device's physical address. That's ARP. Thank you all so much for joining me on another episode of Ryan's Writing Table. I appreciate you all taking the time out of your day to join me here. Thank you so much, and I'll see you in the next one.